one of the most intriguing behaviors that has baffled the quantum world is entanglement. Entanglement is the interaction between isolated particles. How does a discrete particle affect another one from a distance? Quantum mechanics has yet to find a rational explanation for this phenomenon. Here's what some of the experts have to say about entanglement in particular, and quantum mechanics in general.
The most absurd, the most crazy, the most ridiculous prediction that quantum mechanics makes is entanglement. It is impossible to even comprehend. Don't even ask me why. Don't ask me which you're going to, how it works, because it's an illegal question.
Quantum physics is notoriously weird, strange, and counterintuitive.
To this day, still have great difficulty in understanding it.
After you learn quantum mechanics, you're never really the same again.
The short answer is we don't know. This is the fundamental mystery of quantum mechanics, the reason why quantum mechanics is difficult.
This is something we scientists have argued passionately about now for almost 100 years, and there's still no consensus.
The most magical thing is that in quantum physics, an object can be in more than one place at the same time.
Because it may suggest that information has traveled instantaneously, faster than the speed of light, from one particle to another. I don't understand it. I don't know that anyone does. Spooky action at a distance, as Einstein called it.
The rules that govern this subatomic world hint at a universe that's just as mysterious as science fiction. In fact, quantum physics may suggest that reality is simply a figment of our imagination.
Breathtaking testimonials. After 100 years of quantum mechanics, perhaps all these blunt confessions are important of something else. Maybe they indicate that the theorists have not discovered how the subatomic universe works. Maybe they're modeling it with the wrong entity. Maybe it's time to question the particle hypothesis. Under the rope hypothesis, entanglement is a no-brainer. It's not even a mystery. The quantum atom consists of electron beads that orbit the nucleus. When the electron bead falls to a lower energy level, the atom emits a photon, a packet of energy. And when an atom absorbs a photon, the electron bead rises to a higher energy level. Quantum provides no rational physical mechanism for why the electron bead doesn't drift away. Nevertheless, whether electron beads or photons, discrete particles and waves have two fatal shortcomings. They are one-way mechanisms. They can only travel in one direction, and they cannot generate pull. Discrete one-way billiard balls can only push. In contrast, the rope hypothesis proposes that two atoms are bound together by a pair of twined DNA-like threads. A rope-like entity that physically and permanently binds them. The electric thread forms the star-like proton in the nucleus. The magnetic thread coils around and weaves the electron shell that encapsulates the nucleus. The electromagnetic ropes from every atom in the universe converge upon an atom and contribute to its structure. The atom is a tiny heart that expands and contracts, pumping torsion waves to every atom in the universe. When it contracts, it releases a link of rope, a segment known in quantum as a photon. When the atom expands, it reels in a length of rope. By doing so, the atom torques the electromagnetic rope. Light consists of a torsion propagating in two directions along the electromagnetic rope from atom to atom. Three-dimensional torsion waves arrive at your eyes from an atom in the Andromeda galaxy by propagating along the electromagnetic rope. So what is the problem with entanglement? Why is it so baffling to the particle mathematicians? Let's allow the experts to tell you in their own words why they can't explain entanglement with discrete particles.
When two subatomic particles interact, they can become entangled. That means their spin, position, or other properties become linked through a process unknown to modern science. That means if a scientist observes one entangled particle and forces it to spin clockwise, the other entangled particle will immediately start spinning in the opposite direction. That seems intriguing, but it's hardly earth-shattering until you consider that the two entangled particles can be separated by billions of light years. And still, the moment you observe one particle's spin, you've dictated the other particle's spin.
Two particles can become entangled if they're close together and their properties become linked. Remarkably, quantum mechanics says that even if you separated those particles, sending them in opposite directions, they could remain entangled, inextricably connected. Quantum particles can be linked across space. Measuring one thing can in fact instantly affect its distant partner, as if the space between them didn't even exist. The one thing that Einstein thought was impossible, spooky action at a distance, actually happens.
So how does the electromagnetic rope explain entanglement? Let's first get an introduction from David Bohm, a researcher who studied entanglement in great detail.
Both quantum mechanics and relativity suggest the world is not made of separate elements, but it is an unbroken whole in flowing movement, in the sense that things which are far apart are still related deeply. It is possible to have all these things connected together over very long distances into a whole.
What if we assume that all atoms in the universe are interconnected? What interconnects any two atoms is the electromagnetic rope along which torsion waves propagate. From my end, the rope twirls clockwise. Hopefully from your end, the rope is twirling counterclockwise. Now let's reverse the direction. From my end, the rope twirls counterclockwise. Hopefully from your end, the rope is twirling clockwise. Discrete particles have no rational way of explaining action at a distance. That's why the theorists were compelled to invent excuses and ludicrous theories. This is how they ended up confessing that they don't understand how the subatomic world works. They painted themselves into a corner. The electromagnetic rope, on the other hand, is an extended object that binds any two atoms and explains clockwise and counterclockwise spin. In fact, the rope need not move at all. Recall that quantum mechanics alleges that the atom emits energy in discrete packets. Under the rope model, the alleged photon of quantum mechanics is a link of the rope. When the blue thread is on top for the atom over here, the red thread had better be in the top position as it melts into the atom over there, if the link is to preserve its integrity. Both Planck's quantum packet and de Broglie's equation require an integral number of links. Indeed, All these years, the particle theorists were staring at the answer right there in front of them.
When two subatomic particles interact, they can become entangled. That means their spin, position, or other properties become linked through a process unknown to modern science.
Unknown to modern science? What did they bind these two particles with? The theorists had no choice but to link their particles with an extended entity to illustrate how one could influence the other. All they had to do all these years is replace their particles and waves with the electromagnetic rope. Therefore, what is so baffling to particle theorists is easily explained under the rope hypothesis. It's not even an issue. It's kindergarten stuff. All we need to do is abandon the particle hypothesis.